All right, so you should notice that this looks exactly like the graphs that I showed you with F prime. I'm going to zoom in so that you can see what this label is. This one says F double prime, right? So this is a different context. You have to keep that in mind as you go forward. This is F double prime of X. And you'll notice right here, I have the rules for F double prime. If the second derivative is positive, notice one of your note cards should say the original function is concave up. If the second derivative is negative, then the original function is concave down. If the second derivative is equal to 0, then you should look at an inflection point on your original function. Okay, so your second derivative relates back to concave up, concave down. Your first derivative should relate back to increasing and decreasing. All right, so let's think about that moving forward, because as I said, we have the second derivative. That's the label right there. This is the second derivative. So I want to think about where the second derivative is positive. Let me go over here. Positive, positive, positive. 0. Positive means above the x-axis, 0. And then negative, negative, negative. All right. So let me try to see if I can sketch out F. Right? So usually you don't try to sketch F prime and F double prime. It's usually everything goes back to F. So I'm going to go right here and denote, because this denotes something special. You're hitting your x-axis. All right, so let me get out my red pen. And as I go from here all the way to here, my second derivative, F double prime, again, the label on this is F double prime, is consistently below the x-axis, less than 0. All right. So I notice there's a transition, and then I go over here, and I notice that F prime is consistently above the x-axis. All right, so what I'm going to do is I'm going to go right down here and see what that means. Second derivative negative is right there. Means your function should be concave down. Second derivative positive, there it is. Means your original function should be concave up. Okay, so this means that F is concave down over here. All right. So let me sketch that out. Again, I'm only asking you all to give me a general sketch. Okay, so I'm trying to sketch F of X. I can't see it, but I do have some idea of how it's behaving based off of this code switching, right? So my function F should be concave down all the way to this point. So how about something like that, right? It's a sketch, doesn't have to be perfect. And then over here, my function has to be concave up. So there you go, there's a general sketch. So if I gave you a graph like this and I asked you, where is F concave down? You should say negative infinity to 3. And where is F concave up? From 3 to infinity. How would you know that? You sketched out F based off of the rules of F double prime for this particular graph. All right, let's do the next one. So what happens if this one is now labeled, let me zoom in so that you can see what it says, is now labeled F double prime of X. Not S prime, but F double prime. All right, so if you look here, you'll notice that this is F double prime positive, F concave up, F double prime negative, F concave down, F double prime equals 0, F is at an inflection point. So let me go over to my axis and do positive, 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 0, negative, negative, negative. All right, I want to make sure that I'm paying attention. All right, so I want to mark those points where I cross the x-axis. So here, there's one of them, and here's another one. All right, so I know that my arrow goes up to there. I have an arrow in here, and I have another arrow over here. All right, so what's going to happen? Okay, so So if I look at, you'll notice consistently, okay, what throws a lot of students off is they look at the graph and they want to see the behavior of this graph and they say, oh yeah, f is decreasing. No, this second derivative is decreasing, but we don't care about that. If you'll notice down here, the only thing we care about is whether f double prime is above, at, or below the x-axis. That's it. So from here to here, you'll notice what we can say is f double prime is consistently positive. Okay, what can we say about this? You really should try these, folks. This takes a lot of practice. Is that f prime is consistently below the x-axis. And then over here, you'll notice that f prime is consistently above the x-axis. All right, let's get to code switching. If the second derivative is positive, the original function f should be concave up. So f is concave up here, and f is concave up here. And if the second, oops, I made an error, so let's correct this. I made two errors. This should be f double prime, right? Because the graph here is f double prime. This one too should be f double prime, right? So please make sure that you're cleaning that up. So f concave down. So if I forced you to sketch out this graph, then you should be able to tell me, all the way up to, I've done a poor job, it's right here. Your line is right here. All the way up to here, your function should be concave up. So let's see how we're going to draw that. You can exaggerate it if you want. Again, this is f of x. Okay, your original function f of x should be concave up. And then in between here, you should have a function that's concave down. How about that? Right there. All right, and then over here, you should have a function that's concave up again. All right, so if I ask you, where's f of x? Where's f concave down? You should be able to tell me from -1 to 2. If I ask you where f is concave up, you should be able to tell me from -infinity to -1, and then from 2 to infinity. All right, I'm not going to do the last one. It is exactly the same as the other ones. If you have any questions on that, shoot me an email.